This video serves as just a quick review of scientific notation. Scientific notation is the way we make numbers like this unruly one here look more reasonable as a base of 10. So this one would be 1.2 times 10 to the 8th. Or this one over here, these scary decimals, would be more like 6.7 times 10 to the 6th. So this just serves as a quick review of how to get to these more reasonable and manageable numbers. It also has a lot to do with significant figures, mentioned in the previous video, because sometimes we have a number like this that has 1, 2, 3, 4, 5, 6, 7 significant figures. But we are not allowed to report our results to that level of accuracy. We're only allowed 2 significant figures, so we can do this and get it down to those 2 significant figures. So essentially what we're doing is we're just moving the decimal place over and then putting our number to a base of 10. So for instance, for this first one here, let's see how that would work. So basically there's a decimal here that we don't think about. And we're going to move that decimal up towards the 1. So we're going to move it 1, 2, 3, 4, 5 positions. So our number then would be 1.0 times 10 to the 5th. This number here, however, we're going to go the other way. We're going to move our decimal to the right. So we're going to move 1, 2 positions to the right. So this one would be 9.8 times 10 to the negative 2. So if we move to the right, because the number is very small, we end up with this negative exponent up here. For this one, we're going to move 1, 2, 3, 4, 5, 6, 7 to the right, so 9.8 times 10 to the negative 7. This one here, we're going to take our imaginary decimal and we're going to move it 1, 2, 3, 4, 5, 6, 7, 8 positions to the left, 1.02 times 10 to the 8th. So big numbers will have positive exponents, small numbers will have negative exponents. So which of the following is less, 1.8 times 10 to the negative 3 or 1.8 times 10 to the 3? Well, it turns out this one is less. It's going to be a decimal. And what that looks like is we have 1.8 times 10 to the negative 3, so we're going to take our decimal and we're going to move it to the left 3 positions. 1, 2, 3. There's our new decimal, and then we can fill in with zeros. So let's look at that without all of this stuff mucking it up here. Times 10 to the negative 3. We're going to take our decimal and go 1, 2, 3, new decimal, and then backfill with zeros. So this number is actually 0.0018. This number over here, on the other hand, this 1.8 times 10 to the 3, we're going to move our decimal to the right, 1, 2, 3. There's my new decimal, and I backfill with zeros. So this number is actually 1800. Express these two numbers in significant digits. This is to 2 significant digits. So this is where scientific notation helps us to make sure that we're recording our results to the specific level of accuracy. So we want these to 2 significant digits. So basically we can only report this one with these 2 significant digits. So we're going to take our decimal and we're going to move it 1, 2, 3, 4, 5, 6, 7, 8 positions. So this number would be 1.2 times 10 to the 8th. This one here we want to report to 2 significant digits, so it's just going to be these 2. Now we apply the normal rounding rules, so this one is greater than 5, so this one was going to go up to actually be 7. So we move this decimal 1, 2, 3, 4 over, so this number will be 3.7 times 10 to the 1, 2, 3, 4. Negative 4. This number here says express this number to 2 significant digits. Well, that means we're just going to round. So we're just going to basically drop this information, and this number would just be 1.2. No scientific notation required.